In this video, we're going to talk about the 2021 ACSL Finals Intermediate Programming Problem number 2, which is King in Danger. So the problem states, given the state of a game of chess, determine whether the black king is safe, in check, in checkmate, or in stalemate. The king will be the only black piece on the board. Its position as well as all of the opponent pieces will be specified in the input. King is said to be in check if it is on a square that can be captured by an opponent. The king can move one space in any direction. If there's an opponent in that destination square, the king captures the piece and that piece is removed from the board. However, this move would be illegal if it results in the king's new position being in check. There are 4 situations that a king can be in, and in this program you need to identify each situation. So the first one is safe, and that is if the king is not in check and can move to any location where he would not be in check. Then we have check. The king is in check but can move to a location where he would not be in check. Then we have checkmate. The king is in check and every move he could make would put him in check. And then we have stalemate. The king is not in check and every move he could make would put him in check. And then after this, there's just a little bit of a description of an actual game of chess. We're going to have 2 rooks, 2 bishops, 2 knights, 8 pawns, and 1 queen among the white pieces. And these boards here in particular don't have a white king. The king is going to only be the black piece. So we only have the king who's the black piece, and then all other pieces are going to be white pieces. And then we just have some information on our sample inputs and outputs. So we'll just go through those when we code this out. So if you don't know the rules of chess, then we'll just quickly review that. A bishop can move any direction diagonal. So if I have the bishop right here, it can move in this direction. If there were gray squares here, I can move in this direction, or in this direction. And I can capture black pieces. Now, if I have a queen, in addition to going diagonal, I can also go up and down and right and left. So I can go in this direction, this direction, this direction, this direction, down, and here, here, and here. And I can go as far as there are no obstacles in my path. So like this queen right here, it can't go beyond this rook because the rook is in the way. Next, we have the rook. The rook can move up and down and left and right. So we can go in this direction, this direction, this direction, and this direction. And here we also have another rook. So here, 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 and here. And it can go anywhere down. So it can go all the way down here. This one can go all the way up, all the way down, as far as it can go. Now this board doesn't include a knight or a pawn, but let's go through those pieces as well. So let's just call K knight. So if I have a knight here, I can go in any direction where I'm going 2 in some direction and 1 in the perpendicular direction. So I can go here, here, here. I can't go anywhere here because that's not in the bounds. I can go here, here, and here. And if these were in bounds, I could go here and I could go here, but they're not in bounds. And so that's for a knight. And if I had a pawn, the pawn's actually the simplest, let's call it P. It can normally only go 1 spot forward, and this is specifically 1 spot forward. Like it cannot go all the way across the board as much as possible in a direction. Now, if we want to capture a piece with a pawn, so let's say I have a piece here, or I have a piece here, then the pawn can go in that direction or in this direction and capture the piece. And then the king right here can move in any direction for 1 spot. So the king can go here, 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 and here. But the king cannot go all the way down in a direction. So it's not like the queen. So the queen can go all the way down here, but the king can only go 1 spot up. Now that we've reviewed the pieces themselves, let's talk about how we're going to solve this. So the way we're going to do this is we are going to go through every piece that's on the board, and we're going to mark up the locations where it would be unsafe for a king to be. So let's start with the rook. So the rook is going to endanger any vertical spot. So we'll just mark those ones up. And then it's also going to endanger any horizontal spot. Now the second rook is going to do the same. So we'll mark up the vertical spots. And then we can mark up the spots on the right of the rook. And then for the spots on the left of this particular rook, we have a queen in the way. So we can't mark up all the way for just the rook. So we can keep iterating from right to left and keep crossing those places off until we get to the position of the queen. And then we can just break. So we'll cross this part off, we'll cross this part off, and we realize that we've encountered a queen. So we stop right there. And then for the queen, we can mark off any vertical spots as well as the horizontal spots. So we'll mark off the left one, And then for the right, we've already marked this off, and then we keep going, and we encounter a piece right here, so we mark that off, and then we continue. And then the queen can also go diagonally, so we'll mark off this, 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 and this, and we'll mark off any additional ones as well. And then lastly, we have the bishop. So the bishop can go diagonally, so we've already marked off these. So we'll mark off this, and this piece once again. So now that we've marked off all the endangered spots for the king, let's talk about why some of the pieces are crossed off and some are not. So if you see here, most of the white pieces have been crossed off as endangered spots, but the bishop at a1 is not marked off. And the reason for that is because whenever we're at a piece and we're marking off all the places that that piece endangers, we're not marking off the piece itself, but we are marking off any pieces that it meets in its path that are on its team, because the king could potentially hit those pieces, and if the king gets rid of those pieces, then it is officially in an endangered spot, because there's another piece protecting that entire region. Now, once we've marked off all these endangered spots, we need to check where the king is currently and where the king can move. So the king is currently at this location, and this location is currently in check. So we should have marked this spot off too, because the king can be attacked by the queen in this direction. So the king's currently in check, so the king has to move. Well, are there any spots where the king can move? There is one spot, and it's right here. So the king can move here, and it will not be in check anymore. So because the king was in check, but can move to another place where it won't be in check, we call this situation check. So the answer to this would be just check. So now that we've gone over the algorithm, let's go ahead and implement this in code. So here we have our code file. So we have a function, and it's called find king status with a parameter of pieces. So this was the function header that was given by ACSL. And then we also had the sample input that we worked with earlier in our example. So the way the sample works is that we have a bunch of space separated sequences of characters, and each sequence, so this BA1, RD3, so on and so forth, each one of those is going to represent a piece at a particular location. So B is going to represent a bishop, and that's going to be at A1. And then R is going to represent a rook, so that's going to be at D3. And then another rook is going to be at G7, and then a queen is going to be at B3, and a king is going to be at E6. And then we have other pieces like knights and pawns. So pawn is going to be a P, and a knight is going to be an N. So the first thing we're going to do is just split up our pieces into a list. So we'll say pieces is equal to pieces, and then we're just going to get rid of any spaces on the ends, because I remember one of the inputs when I was coding this out for the competition had an extra space at the end, or maybe an extra new line, and so that might have been an error on the part of the competition hosts, but we just want to get rid of any of those unnecessary spaces or new lines. So dot strip at space, and then also dot strip at new line. And then we'll also just split this at spaces, so split at a space. The next thing we're going to do is create a set called unsafe positions. So unsafe positions is equal to a set. And this set is going to represent all those positions that the king cannot move to. And the king could potentially be in an unsafe position, so we also want to check for that too later on. Now we want to know where the king is currently. So we'll say king loc. For now we'll say that's equal to 0, 0. And there's only one king, so when we go through all the pieces, we'll figure out where the king is. And then just to make it easier to map the positions, right now we have the positions in terms of a letter and then a number. And so if we recall from the chessboard, the letters read from left to right, and then the numbers read from bottom to top. Well, I'm just going to make it so that the rows are going to be read from top to bottom, and the columns are going to be numbered rather than lettered, because it'll be a lot easier to just work with those. So in order to do this, we just have to create a conversion dictionary. So we'll say alpha num is equal to just A, B, C, D, E, F, G, H at I. And then this key is going to be mapped to a value of just I, for I in range 8. And that'll map accordingly. And then we also need a function called position valid. So position valid is equal to lambda RC, such that 0 is less than or equal to R is less than 8, and 0 is less than or equal to C is less than 8. So we're going to use this function when we are evaluating the king's position, but we're actually not going to use this function when we're evaluating the possible positions that each piece can go to. And the reason for that is because we actually don't care. It's not going to give us any errors because the king anyways can't move to those pieces. The check will already be made by the king. So there's no need to make those additional checks to make sure if a position that a piece could potentially move to is valid or not. And then occupied is equal to another set, and that'll be a set containing all the pieces and their locations. So let's first populate occupied. So we'll say for piece in pieces, piece type rloc and cloc is equal to piece at 0. So each of these are going to be a string. So we're going to say that the first character is that piece. So piece at 0, and then the second character is going to be the r location. So that's the row. And the way we can transfigure this is we'll say 8 minus int piece 2. And then the c location, so that's the column of this piece, is going to be alpha num at piece 1. Next, we're going to make a check to see if the piece type is a king. So if piece type is equal to k, and we're just going to continue. And the reason for this is because we don't want to count the king as part of the occupied set because the king could potentially be in check, and we want to make sure that the king isn't regarded as any other type of piece, as any obstacle for any piece that's going in that direction. Because unlike the other pieces, any piece can get rid of the king because they're opposing pieces. And then we'll just say if this is not true, occupied.add a tuple that is the r location and the c location. Next, we need another for loop, and this is going to be the main for loop that allows us to just add all those endangered spots by those pieces. So again, we'll say for piece in pieces. And again, we'll get this same line. So we'll just duplicate that, move that down. And now we have to check for all the different kinds of pieces. So if the piece type is a king, then we're just going to set the location for that king. So king loc is equal to r loc and c loc. And we'll just continue. Now, if the piece is a queen, so elif piece type is equal to queen, then we need to check for unsafe positions in the row, the column, the backwards diagonal, and the forwards diagonal. And so we're going to actually create functions for each of these because we can reuse them. So we'll say for now just row check r location, c location, and we'll pass on occupied and unsafe positions as well. And we'll duplicate this a few times. And for each of these ones, we'll say that we want to check the column. So call check and forward diag check, and then backward or back diag check. So that'll just check all the possible locations that the queen can go to. And we'll just write all these functions. But first, let's write out the main thing. Now, otherwise, if the piece type is a rook, we can only go through the rows and columns. So we'll just take lines 20 and 21 and copy them over down to 25 and 26. And now if the piece type is a bishop, so elif piece type is equal to b, we're going to say that we want to check for unsafe positions in either of the diagonals. So we'll copy lines 22 and 23, and we'll move those here. And so that covers all those locations. And then we can check the pawns. So the pawn is going to be very easy. Elif piece type is equal to p. And if that's the case, if we have a pawn, then unsafe positions are going to be where the pawn can go directly one space up to the right and diagonal, and one space up to the left and diagonal. So this is going to be unsafe positions dot add. So we're going to add that tuple location, rloc -1, so the previous row, and that's going to be actually one above, and then the previous column. And then the same thing, except we're going to make this the next column. So either of those are dangerous spots. And finally, we need to check if the piece is a knight. So elif piece type is equal to n. And here's where we're going to create a list called knight dirs. And that's going to be all the possible changes in direction that a piece that is a knight can go in. So we'll create a list, and inside this we'll create individual lists. So we'll say to 1, to -1, -2, 1, -2, -1, and then we'll do the reverse. So 1, 2, 1, -2, -1, 2, and -1, -2. So these are all the possible changes in location. And then we go through every direction here. So we'll say 4k in knight dirs. We'll say unsafe positions dot add, and we'll just add that new location. So rloc plus k at 0, and then cloc plus k at 1. All right, so now that we've done all this, let's go back to these functions and let's actually implement them. So we'll start with row check. So at the top here, we'll just define row check with these parameters. So I'll copy all of these over and I'll paste them here. And inside this function, we basically want to check two ranges. And that's actually going to apply for all the functions. So the two ranges we're going to check are all going to be on one side of the piece and then the other side of the piece. So with the rows, our two ranges, we'll put them into a list. So ranges is equal to, the first range is going to be range from clog plus 1 to 8. So that's everything to the right. And then range clog minus 1, -1, -1. So that's everything to the left of the piece. And then for range in ranges, so for RG in ranges, and then we're going to go through that range. So for C in range, we're going to say unsafe positions.add at rlog and C. And now that we've added this unsafe position, if the position is actually also in occupied, then we can't go further. So if rlog C in occupied, we'll just break. So that's for the row. Now we can do the column. So we'll say def call check, and we can paste the same parameters. And inside here, we'll define similar ranges. So ranges is equal to range, but this time we're going to go from rlog plus 1 to 8. And then our second range is going to be the other side. So that's going to be going up. So range rlog minus 1, -1, -1. Now for range in these ranges, so for RG in ranges, we're going to say for R in range, we'll say unsafe positions.add a tuple that's going to have R as our row and clog as our column. And then again, if we're at an occupied position, if our clog in occupied will break. Now we have to do the two diagonal functions. So these ones are a little bit harder, but they're still the same idea. We just have to use some mathematical transformations to figure out how we're going to count those two diagonals. So we'll start with the forward diagonal. So we're going to say def forward diag check. We'll do the same parameters. And so recall that this one is going to be this direction of a diagonal. So this diagonal. And inside this function, we'll declare our ranges. It's going to be the same as line 9. So ranges is equal to range rlog plus 1, 8. And then we'll say our other range is going to be range rlog minus 1, -1, -1. And then we'll say for range in ranges, for R in range, we're going to add this following position. So we'll say unsafe positions dot add, and the tuple we're going to use is R, and then rlog plus clog minus R. So if you want to write this out, you can actually compare this with the example. We're going to use the sum of those two locations, and then we're going to subtract the current row that we're at. And that ensures that we're able to use that sort of forward diagonal. So it'll be easier to go from bottom left to top right. And then once we check this, we need to make sure that it's also not occupied, because if it is, we'll just break. So if rlog plus clog minus R in occupied, we want to break. And finally, we need to write our backward diag check. So this is going to be this diagonal. So def back diag check. We'll use the same parameters. And in here, we'll say ranges, again, same line as 17. Ranges is equal to range rlog plus 1, 8. And then range rlog minus 1, -1, -1. So those are going to be those two directions in rows. So we'll go first to the bottom, like we have here, and then we'll iterate to the top, like we have here. And then we'll say for RG in ranges, for R in range, we're going to say unsafe positions dot add, and the position we're going to add is going to be R, and then R plus clog minus rlog. So this is a little bit different, but essentially what we're doing here is we're taking the difference between these two original locations, and we're adding that to every iteration of R. And once we have this, we can say if R plus clog minus rlog is occupied, so in occupied, and if that's the case, we'll break out of this. And that pretty much covers it for all our functions that we're going to check for endangered positions. Now, once we have all these, we can go back down, and we've already executed these functions down here, or we've called these down here. And the final thing to do is to check the possible states of the king, because we haven't actually checked the king yet. We've checked every other piece. So we're going to go down here, and we'll say king can move is equal to false. So that's the condition that represents whether the king is able to move from their particular spot. So the way we're going to do this is we're just going to check all those different possible locations. So we'll say for dr in -1, 0, 1, and for dc in -1, 0, 1. So these two loops are basically saying that we're iterating through every delta r, so every change in r, and then for every change in r, we're iterating through every possible change in c. Now, we'll say that the new r and new c, so nr and c, is equal to king loc at 0 plus dr, and then king loc at 1 plus dc. And now there are a few conditions we need to check. So the first one is if not position valid at nr and nc. So this is where we're going to call this position valid function, and this is because we want to make sure that where the king can move is actually valid, because if the king's trying to move to an invalid position, that's just not possible. So if not position valid, or now the second thing is dr is equal to 0 and dc is equal to 0, because if that's the case, the king didn't actually move. So this cannot contribute to whether the condition is true. So we'll just continue here. And now we'll check if nr and nc is not in unsafe positions. That means we can actually move there. So king can move is equal to true. And we'll just break out of this because there's no longer a need to check anything. And then if we go through every iteration of this for loop, so we'll say else, we want to continue, otherwise we want to break. So this code segment right here, this allows us to break out of both of these loops. So if we break here, we're not going to run this else, so we'll just break. But if we don't break, then that means we go to the else and that tells us continue. So we won't actually get to this break. So it's a nice way in Python of doing a multiple loop break or nested loop break. And now that we have this, now that we've checked to see if the king can move, we also need to check to see if the king is safe currently. So king safe currently is equal to king loc not in unsafe positions. So this is basically saying if the king's particular location is in the unsafe positions, then this is going to be false, but otherwise it'll be true. And the final thing to do is to actually return our necessary states. So there are 4 possible states: safe, stalemate, check, and checkmate. So safe is going to be if king safe currently and king can move. And if those two are both true, we return safe. Otherwise, if the king is safe currently and the king cannot move, so not king can move, then we return stalemate. And then our third condition is elif not king safe currently and the king can move. That means we're in check. And finally, the only possible condition is going to be checkmate. So else return checkmate. And that's it for this program. So essentially what we did here is we marked off all the endangered spots by each of the pieces except for the king, and then we checked to see if the king can move and if the king is currently safe. And that's how we can return any of these 4 states. Alright, so now that we've done this, let's go ahead and test this code. So we'll first test it with our sample input, and then we're going to test it against a testing program that I created that mimics the original code validation tool used by ACSL. So first, we have the sample input. So we'll just say print find king status of sample input. And let's run this and we will see that we get a check. And this was what we were expecting. Alright, so now that we've done this, let's run this against all our tests to see if this actually works. So in order to test this against the testing program, we'll just say import king tester. And we'll just stop this right here. And then let's run this again. And this time we see that all the test cases have passed. So all 15 test cases. So it looks like we were successful. That's it for this video, and I hope this was helpful.